Hi everyone, my name is Thomas Kim. Today is April 7th, 2021. This is the 6th episode about Fourier transform and FFT from scratch. This is my last episode. I will implement the complete FFT algorithm. I implemented the complete FFT Cooley-Tukey algorithm in C++ approximately 2 years ago. When I implement this algorithm, I used CPU-based recursive algorithm, and I have been wishing to implement this algorithm in parallel. After a few weeks later, I think now I can implement FFT algorithm in parallel without using recursion. For such purpose, I will learn parallel prefix sum algorithm first to practice how to use compute shader. Hi everyone, my name is Thomas Kim. Today is April 2nd, 2023. This is my 51st episode for C++ electricity and magnetism, vector calculus. In this episode, we will learn compute shader parallel prefix sum algorithm. We will also learn synchronization using barrier function. In this episode, we will be using C++ 20 ranges library. We will compare OpenGL compute shader with CUDA. We will learn synchronization using barrier function. We will also learn how to gracefully exit OpenGL application using glFW set window should close function. To follow my current session, you need up-to-date C++ library extensions. Right before filming this video, I updated my C++ library. Also, I assume you have watched my previous video, episode 50, OpenGL Compute Shader Parallel Prefix Sum 1. Please double-click this link. If you haven't watched my previous video, OpenGL Compute Shader Parallel Prefix Sum 1, it might be difficult for you to follow my current session. Show more, click this link to download our previous source code. Unzip it, rename folder 51, copy, paste it in your working directory. Open up Visual Studio Code, Electricity and Magnetism. From folder 51, double-click template.cpp. I will delete this part. Then right-click, copy, paste, rename prefix sum. Ctrl V, close template.cpp. In this part, I will include CPG, chrono random.hpp, namespace, CCR, CPG, chrono random, using unsigned int. We will be using bitwise left shift operator. When we use bitwise left shift operator, we have to use unsigned integral types. Otherwise, you are causing trouble. So we defined uint, unsigned int. Now here, context per unsigned int, num elements. I will set it 20, 48 or 2k elements. Now open up this command prompt. You should be able to see Intel SQL OpenGL Programming Guide 9th edition. This command string dir cd 051 parallel prefix sum icx cl prefix sum.cpp at resp.txt, hit enter. You should be able to build successfully. CLS I You now see Compute Shader and Texture window. Now I will close it. In this section, I will disable base display function. Instead, glFW set window should close base MP window. Then we can return non-zero value. Any non-zero value is good enough. This function terminates OpenGL application if non-zero value is specified here. With this, we rebuild CLS I. It ends automatically. For example, if you put message here, std cout display is called CPG, and if we rebuild CLS I, display is called, our function works correctly. I will disable it like this. In the private section, enum input output. So input is 0, output is 1. std vector plot input data copy paste CPU output GPU output. Here I will define using vector t std vector plot. Also constructor unsigned int byte count size of plot times num elements. Now in the initialize input data resize num elements, we allocate memory CPU output. This is GPU output. In this section, void prefix sum const plot input plot output int elements. I would say input data output data plot f 0.0 f for int I 0 I less than elements plus I f plus equal input data I output data I equals f. This is CPU implementation for prefix sum. Very simple, but we will implement it using GPU in parallel. Now, in this section, auto generator CCR random generator int 1 up to 9 CCR random parallel field input data we pass generator. Now we use C++20 range library. Auto first 8 input elements input data pipe std views take 8 std cout input data first 8. We print out first 8 input elements, then semicolon. Auto last 8 input elements std views counted input data end minus 8 std cout last 8 input elements last 8 cpg and there. Now in the command prompt once again we rebuild CLS I. We generated 20, 48 elements with a random number. Then we displayed first 8 elements. These are random numbers. Then last 8 numbers like this. These are random numbers. Each time we execute, we have different random numbers. Now, in this section, we call prefix sum. This function bypassing input data, CPU, output, NUM elements. Then we copy this part, paste it here. It should be data, also data. First 8 CPU output, CPU output, CPU output. First 8 CPU output, last 8 CPU output. It should be CPU output, CPU output. I misspelled. With this, we build again CLS I. So this is input data 9, 9. 9 plus 9, 18. 18 plus 8, 26. These are correct result using CPU algorithm. Now we implement using GPU. Click this button, prefix sum.conf, Ctrl B, version 460 core, layout, local size X, 1024 in, layout binding 0, coherent with only buffer block 1, float input data GL workgroup size X, semicolon, copy, paste, binding 1, write only block 2 output data. I will arrange side by side. If you scroll up, in this section we defined input 0. Input 0 represent binding point 0 for input data. Output 1 for binding 1 output data. Local size X is equivalent to block dim X in CUDA. Here, workgroup size X is equivalent to block dim X in CUDA. So, local size X is equal to global size X. We set it 1024 here. Now, in this part, shared float, shared data, GL workgroup size X times 2. We allocated this amount of memory, or 1024 times 2 equals 2048. We defined num elements 2048. This is number of elements. This keyword shared is equivalent to 2 underscore shared in CUDA. So we are allocating shared memory. In our previous episode, episode 48, in this video we learned buffer object. Now, in this section, void main unsigned int id gl local invocation id x. This corresponds to thread dx x in CUDA. Unsigned int read ID. Unsigned int write ID. Unsigned int mask. Constant unsigned int steps. This is plural. Log 2 GL workgroup size x plus 1. This is log 2 GL workgroup size is 1024, which is 2 to the 10th power plus this 1. So it becomes 10 plus 1 or 11 is steps. From shared data ID times 2 input data ID times 2 shared data ID times 2 plus 1 equals input data plus 1. Now we need barrier. This is equivalent to sync threads in CUDA. If you are unfamiliar with the shared memory in CUDA, you can control-click and read about shared memory in CUDA. If you scroll down, you can find sync threads, also shared. This is equivalent to shared memory in OpenGL. Also, barrier is equivalent to sync threads in CUDA. Now, for unsigned int, step 0, step less than steps plus plus step. Mask equals 1 step minus 1. This is equivalent to 2 to the step power minus 1. ID read ID shift right step, then step plus 1. We need parentheses, then plus mask. Please understand, we need extra parentheses before we perform addition with mask due to operator precedence. Now write ID from read ID plus 1, then plus ID mask. This part returns remainder of ID when divided by 2 step. Now shared data write ID equals shared data with ID. Now we need barrier synchronization once again. We have to inform other work items or threads to complete the task up to this point, or other work items of the current work group or current block in CUDA. After loop output data ID times 2 equals shared data ID times 2 output data ID times 2 plus 1 equals shared data ID times 2 plus 1. For more information about this part, please refer to OpenGL Superbible 7th edition from this book in the Part 2, Chapter 10, Examples compute shader parallel prefix sum. In this part, this explanation. In the private section, GL uint program scroll down. In this part, I will make demarcation shader info shaders curly brace GL compute shader, comma, we provide prefix sum.comp, prefix sum.comp, copy, paste, remove trailing, comma, GL none, null, semicolon, program, load, shaders, we pass shaders. With this, we build again. CLS I made syntax error 41. Implicit cast from float to int. Also 61. 41. Here I will cast uint like this. Also 61. Read ID. We rebuild CLS I. Now our program is built successfully.